Here we have a statically indeterminate beam subjected to a distributed load. We wish to analyze it using the force method. The beam has a degree of indeterminacy of 2, so we need to pick 2 of the reactions as redundant forces. Let's make the vertical support reactions at B and C redundant. After removing the redundant forces, the beam is going to deform like this. We refer to the vertical displacement at B as delta B and call the vertical displacement at C delta C. Then we can write the compatibility equations this way. To solve for the unknowns, we first need to calculate these displacements. Here's how we calculate delta B. First, we need to write the bending moment equation for the statically determinate beam under the applied load. Here there are 3 such equations. One for the left segment of the beam, one for the middle segment, and one for the right segment. Next, we replaced the applied load with a virtual vertical unit load placed at B and write the moment equation for the beam. There are 2 such equations, one for the left beam segment and one for the right beam segment. To calculate delta B, we need to integrate m times m star. We repeat this process in order to calculate delta C. Here are the bending moment equations due to the virtual unit load at C. And here is delta C. We have 4 more displacements to calculate. First, let's determine delta BB. This is vertical displacement at B due to a vertical unit load applied at B. Since the unit load and the virtual unit load are applied at the same point and in the same direction, m and m star are going to be the same. Here are the bending moment equations. And here is the equation for delta BB. Delta CC, vertical displacement at C due to a unit load placed at C, can be calculated in the same manner. Here are the moment equations and here is the displacement. Next, we determine delta BC. This is vertical displacement at B due to a vertical unit load placed at C. In this case, m and m star are not the same since the real load and the virtual load are applied at different locations. Here is m. Here is m star. And here is the integral of m star. Finally, we calculate delta CB, vertical displacement at C due to a vertical unit load at B. What we referred to as m when calculating delta BC becomes m star here, and the m star we used for delta BC becomes m here. Not surprisingly, delta CB equals delta BC. Now we can write our compatibility equations and solve them for the redundant forces. The remaining unknown reaction forces, there are 3 of them, can now be calculated easily using the equilibrium equations.